Righto, so this will be the last video for today, talking about strictly increasing and strictly decreasing functions. So functions are strictly increasing if x2 is greater than x1 implies f of x2 is greater than f of x1. So what that means is that as we move to the right, x2 comes after x1, then the graph rises. So the value of the function at x2 is greater than the value of the function at x1. And likewise, it's strictly decreasing if when x2 is greater than x1, it implies that f of x2 is less than f of x1. So that means the y values have gone down as the graph has moved to the right. Now, this is a bit of a funny one because, this actually means that turning points can be included because, for example, as we move to the right on this graph here, we could see that this turning point is lower than this point, say, here, for example. And what that would mean is that then it's still strictly decreasing over this interval, including that turning point. So I just drew this here to really highlight that point. And so we could say that this is strictly decreasing over the interval x is an element of, now we can say 1 to 5 inclusive if we want to, because for all of these values going to satisfy the condition where it is decreasing, or we could say x is an element of 1 to 5. And in both cases the answer is correct. So it is completely up to you which way you choose to write that, but just know they are both correct. Whoa, how did I do that? Just pause the video. Anyway, I've moved on to this example here. So this is looking at a graph, and we're looking for specific places. So the first thing is being able to actually read this information here. So for the graph of f such that the domain is all real numbers and the codomain is all real numbers, so it's this graph right here, okay? Find x such that the gradient is greater than 0. So the place where the gradient is greater than 0, well, we could say it's just this section here where it's going uphill, okay? So that's between -1 and 3. And this is a little bit different to the previous example, in that this isn't talking about strictly increasing or strictly decreasing. This is saying where the gradient is greater than 0. So at these turning points, the gradient is equal to 0, which means we can't include them. Okay, so that's why we have to have round brackets in this case. We're looking now for the places where the gradient is less than 0. So where it's going downhill, which is this section here, and this section here. So we have two different sections, and the way that we're going to write that is -infinity, which always has a round bracket, going to -1, then union, and it goes from 3 on to +infinity. There we have it. And the last part is x such that the gradient is equal to 0. So what we could say is that, well, we use the set notation and just say that it's equal to 0 at -1 and also at 3. Those are the two places where the gradient is equal to 0. Anyway, I'll leave the video there and see you next time.